What up, mathletes? Whoop whoop! All right, welcome to Math 2. And like magic, the learning target appears. I will use properties of parallelograms to solve problems. That little symbol right here stands for parallelograms. If it's drawn better, it helps. Take a minute, do the warm-up, ready, set, go. When you finish, feel free to write down the vocab today, which is parallelogram, a quadrilateral, that's just a four-sided figure, with both pairs of opposite sides parallel. Where's my coffee cup? That's what I need. So you can pause this or just wait. I'm going to pour myself a cup of coffee real quick. Boom, super professional video, right? Okay. So again, throughout this video, I'm assuming you pause it, try things out, and then check back with me, or when I flash vocab and stuff on the screen, I'm not going to leave it long because, again, you have the power of pause. And I don't need a big, long video, right? All right, so it says parallel lines M and N. So we have M and N are parallel. Boom, they're parallel, okay? They're cut by a transversal T. Boom, that's a transversal. True or false? Angle 6 is congruent to angle 1. Well, I don't, or transversals S and T. No, angle 6 is congruent to angle 2. Those are corresponding angles, but it is not congruent to angle 1. So that's false. Yeah. Let's see. Angle 12 is congruent to angle 13. Angle 12, angle 13. Boom. That is true. These are alternate interior angles. Interior angles. Alternate interior angles. So here's how it works, guys. If they're on opposite sides of the inside, they are congruent. Angle 4 and angle 11 are supplementary. Angle 4 and angle 11 are supplementary. If I knew that S and T were parallel, then yes, that would be true. But I'm not told that S and T are parallel, so I can't assume that. So for right now, that's false. Now let's try this again. Suppose lines M and N are parallel and that S and T are parallel. Okay, now we're talking something different. Angle 6 is congruent to angle 15. Let's see, where's angle 6? Angle 6 is right here, and angle 15 is right here. Yes, those would be alternate interior angles. Looking at those as the parallel with the transversal N. And so, yeah, those are congruent. How about angle 4 is congruent to angle 13? Angle 4 is congruent to angle 13. Turns out, yeah, those are congruent. Those are opposite sides. This basically created a parallelogram. That's a theorem later, but those are definitely congruent. Angle 4 and angle 11 are supplementary. Yes, consecutive angles inside of a parallelogram are congruent. This is true. Or supplementary, not congruent. So there we go. Some of this, you wouldn't really know how to answer it until we learn what we're about to learn, but that's what we're going to show you. So without further ado, make sure you have this written down. Pause if you need to. Let's move on. I've got some stuff for you guys to write down. So for the next, really for all the theorems, but we're going to do it once on each page, I just want you to write up top here, if a quadrilateral is a parallelogram, again that's a symbol for a parallelogram, this is for the theorem 7.3 and 7.6. Instead of having to write this 4, 5, 6 times, we're just going to have to write it twice today. Here's what I know, theorem 7.3. Its opposite sides are congruent. So side JM is congruent to KL, and side JK is congruent to ML. Okay, those opposite sides are congruent. Again, pause as we go, write it down, and boom, I'm going to go pretty quick. What else do I know? I know its opposite angles are congruent. We talked about that just a minute ago in one of the warm-ups. So angle M is congruent to angle K, and angle J is congruent to angle L. Okay, opposite angles are congruent. Theorem 7.5, its consecutive angles are supplementary, and that's what we talked about just a second ago with angle 4 and angle 11. Once we knew that both sets of transversals were parallel, then any consecutive angle, so x plus y, so these angle J plus angle K is 180 degrees, angle x plus angle M is 180, or angle J plus angle M is 180 degrees, angle M plus angle L is 180 degrees, angle L plus angle K is 180 degrees. Any two consecutive angles, those are angles right after each other, are 180 degrees. And last but not least, again, you guys, you have the power of pause. So if I move past your writing, pause it, whatever you need to do. If a parallelogram has one right angle, we see this one right angle here, then it has four right angles. And here's why. If this is right angle, I'm told that these two angles are supplementary, right? If they're supplementary, they add to 180, which means angle M has to be 90. But I'm also told M and L are supplementary. Therefore, 90 plus 90 is 180. Do you see how that works all the way around? It forces all four to be 90 degrees, and it forces it to be a rectangle or a square. Awesome. All right, moving on. So given quadrilateral PQRS is parallelogram, so we're told this is a parallelogram. Find the measure of angle R and the length RS. Well, let's look at this. What do I know about consecutive angles in parallelogram? They add to 180 degrees. So I'm going to take the measure of angle R equals 180 degrees minus 59 degrees. What does that equal? Well, 121 degrees. Boom. And then we want to find RS, so this length right here. Well, this is the same as QP, which is 3.9. So RS equals 3.9 centimeters. Don't forget those units. They matter. That's it. That's it. Isn't that nice? Boom. Okay, let's go on to this. Again, I want you to write down one more time if a quadrilateral is a parallelogram for theorem 7.7 and 7.8. Then what do we know? Its diagonals bisect each other. So when I do these diagonals, they cut each other in half. So AP right here is congruent to PC. In the same way, we know that DP is congruent to PB. And notice we start creating some triangles. We can start creating some triangle congruencies. That's where it's going. Speaking of triangles, again, pause this if you need to. Let's look down here. What do we know from theorem 7.8? Then each diagonal separates the parallelogram into two congruent triangles. So if I just draw one diagonal, then I can say the triangle ABD is congruent to triangle CBD. If I had instead drawn the other triangle, I could say, so if I had instead drawn this diagonal right here, same thing would apply. I could say triangle ACD is congruent to triangle CAB. See how it creates another set of two congruent triangles. So just keep that in mind. And that's if I'm talking about these triangles right here, right? So it doesn't matter which diagonal you use. Awesome. Let's look at this last problem, or we got two problems left. It says find the values of X, Y, and Z in parallelogram QRST. Well, let's figure this out. Okay, well, that this side is congruent to this side, so TP is congruent to PR. Congruent to PR, right? Because the diagonals bisect each other. So I can just say TP is 2y minus 5, right? Is congruent to y plus 4. Again, pause this, solve it if you need to. Ready, set, go. I'm going to subtract y from both sides and add 5 at the same time. That is 2y minus 5, yes. So I get what? Y, boom, equals, I should have wrote congruent here. This is an equals thing. 9. So now I know what y is. Y is 9. Okay, now where's x? Well, look over here. I know that these sides are congruent, correct? So that means I can say if QT is congruent to RS, then 5x equals 27. Doesn't have to be nice. Divide both sides by 5, and we get that x equals 27 fifths, which could also equal what, 5.4, right? Because 5 goes to 27 5 times, leaves 2 fifths, which is 0.4. All right, so we've got x. Now let's look for z. Where's z at? 3z. Oh, these would be alternate interior angles. So I know that angle 3z is congruent to angle 33. So boom. 3z equals 33. Divide both sides by 3, and we get that z equals 11. Boosh! We have solved for x, y, and z. I'm trying to move it around so it doesn't get blocked. Okay, this last one looks to be the most challenging, but it's actually not that bad when you start getting used to it. I'm going to zoom in on it, though, because it can be a little bit jarring as you figure it out. Okay, let's read this. Marlene is making a parallelogram-shaped earring. Find the perimeter and the area of one of the earrings round to the nearest tenth. Well, perimeter is just distance around. So it's going to be, we've got some, it's going to be two of these lengths, right? Because these are the same. It's almost like the widths. And two of the lengths. Okay, so we just need to find distance around for perimeter. That's actually the heart of the problem. So I'm going to start with area. Because, are you guys ready for this? The area, remember, a diagonal splits this into two congruent triangles. So if I find the area of one triangle, I can multiply it by 2, and I get the area of the whole thing. And the area of a triangle is just equal to 1/2 base times height. And let's look at this. What's the base? 1, 2, 3, 4, 5, 6. So it's a distance of 6, and then the height, 1, 2, 3, 4. 4. So this just equals 1/2 times base of 6 times the height of 4. And then don't forget, what do I need to multiply the whole thing by? I need to multiply the whole thing by 2, because I need 2 of them. Well, don't these 2's cancel out? And I'm just left with 6 times 4 equals 24. Boom. So we know the area is 24. The perimeter is a little different. Because perimeter, I need to find a distance, so I'm going to need to actually find this hypotenuse right here, right? Because think about it. Doesn't this look like a triangle? If I were to turn it sideways, this is a triangle with a leg of 2, a leg of 4, and we don't know what the hypotenuse is. But what I do know is, remember that whole a squared plus b squared equals c squared? So I know that my c is equal to the square root of a squared plus b squared. And since, let's call my a 2 and my b 4, right? 2 and 4. Then I'm going to have 2 squared plus 4 squared, which is just 4 plus 16. And that is going to be the square root of 20. So this equals the square root of 20, which is said to round to the nearest tenth. So that's approximately what? Found it. Second function, square root 20. It's about 4.5. Okay? 4.5. So now I know I've got this length of 4.5. And I've got this length of 4.5. Okay? Now I need to find these two lengths. And to get that, let's see, I can make a same type of triangle, right? It's going to have a height of 4. And this distance right here is going to be 1, 2, 3, 4. Ooh, so I have an A and B that's, oh, you guys can't see me. I'm so sorry. I just drew this little length right here, and I said, hey, I have a triangle with a height of 4 and a length of 4, and this hypotenuse is what we're needing. So if my A and B are 4, I'm going to have that my C is equal to the square root of 4 squared plus 4 squared, which is just 16 plus 16, or the square root of 32. Let's try that out. Second functions, wrong one. Second function, square root of 32. That's about 5.7. So now I know this is about 5.7, so I got two 5.7s, two 4.5s. Let's just add those together. So the perimeter equals 2 times 4.5 plus 2 times 5.7. See, I know this is 9. What's that? 11.4? Yeah. So this equals 20.4 units. Up here I should probably say units squared. Also, something I want to add. So check that out. Isn't that awesome? Works out pretty good. We use our distance formula a little bit. Find that, or actually our Pythagorean theorem to find the hypotenuse. But up here I want to add something to this. The area of the parallelogram equals 2 times the area of the triangle, which is what we really did. Because we multiplied times 2, right? So I just want to say that. I want to make sure and get that out there. It's good stuff. Awesome. All right. Well, with that said, guys, we're done. This is getting into some thick stuff, so keep on plugging away. You guys are going to learn and be amazing. Peace out.